raise his standard of living and to become more knowledgeable about his world. He's had his share of successes and his share of failures. Man has come a long way since he first carried his tool, and since the invention of the wheel, he has traveled down many bumpy roads in developing the latest in a long line of military vehicles. Man has learned to give his tools and equipment regular attention in order to guard against depreciation and loss of efficiency. Wear and tear of normal everyday use take a heavy toll of equipment unless it is properly maintained. With proper maintenance, military vehicles are designed to perform at top efficiency regardless of terrain and under the most adverse conditions. Of course, prior to performing any type of maintenance, you must first thoroughly clean the vehicle and conduct an after-operations inspection. The expert mechanic knows that damage can be caused by dirt and sand trapped in the grease or oil which is needed to keep the vehicle operating. In addition to routine maintenance after normal field operations, there are certain specific maintenance requirements that must be performed. During this specific maintenance, special attention is given to the wheel bearings and seals of the vehicle. The procedures followed when checking wheel bearings and seals generally apply to all wheel vehicles. Specific instructions can be found in the vehicle's technical manual. In spite of the advances made in automotive engineering since the invention of the Model T, one fact should be remembered. Wheel bearing maintenance principles have remained unchanged, as we shall demonstrate on this M35A2 cargo truck. Safe working conditions are always in the forefront of a good mechanic's mind. In the shop or in the field, the vehicle must be parked on solid level ground and blocked securely if you are to work safely. The experienced mechanic will first loosen the wheel stud nuts before jacking up the vehicle, thereby making wheel removal much easier. This truck has been exposed to a great deal of mud, sand, and water, and requires a thorough inspection of the wheel bearings and seals to determine their serviceability. As we've indicated earlier, this inspection is required over and above normal maintenance after such operations. Provide a clean area in which to place all the components you remove. For although lubricants have properties which minimize friction, these same properties can trap grip, which can virtually ruin wheel bearings. To remove the wheel bearings, first remove the drive flange. Next, straighten the bent portions of the adjusting nut lock. Then, using the wheel bearing nut wrench, remove the outer adjusting nut. Nut lock, and inner adjusting nut. Now move the drum forward and backward until the outer wheel bearing is exposed enough to grip by hand. Remove the bearing and look for any apparent damage such as broken or cracked separators, broken or cracked rollers, signs of overheating, fitting of rollers or raceways, and metallic particles. Finding none, place the bearing into a pan of cleaning solvent for further cleaning and a more detailed inspection. Bearings may be cleaned by several methods. In field operations, you probably use a brush and a pan containing solvent. In fixed direct support shops, a degreaser such as this will be available. Immediately after cleaning, dry the bearings by using compressed air that's double filtered. The use of unfiltered air is not authorized in bearing cleaning operations due to the possibility of moisture or foreign matter entering the bearing assembly. Therefore, compressed air lines must be equipped with moisture filters. Care must be taken to prevent spinning of the bearings by force of air, since any dry particles of dirt remaining in the bearing may scratch the critical surfaces, or the spinning action may spoil the rollers or raceways while the bearing's in an unlubricated condition. After cleaning the bearing cone, use a clean cloth to clean the bearing cup that is pressed into the hub. Then make a visual inspection of the cup, feeling for pits, cracks, or roughness with your hand. Too bad. This bearing cup must be replaced. To remove the bearing cup, use a special tool called a remover and replacer. some help here, ask a buddy to hold the drum while you install the tool. Make sure the bolt is screwed snugly into the remover and replacer. Using a hammer, drive out the unserviceable cup by striking the driving bolt. This may be difficult, as the cup may seize sometimes into the hub. The reconditioning of anti-friction bearing cups is not authorized. Therefore, this unserviceable bearing cup is disposed of as scrap. The remover and replacer is attached to the new bearing cup, and the driving bolt is drawn up tight. After you have properly attached the cup to the replacer, align it into the hub. Then, with a hammer or mallet, strike the driving bolt until the cup is seated. The inner bearing seal prevents the wheel bearing lubricant from entering the drum and damaging the brake shoe. Therefore, with a clean cloth, clean the inner seal and inspect it for roughness, cracks, or other damage. The seal proves to be in good condition. If the bearing seal is found to be unserviceable, replace it. Notice how the sealing element is rough, scarred, and cut. Also notice the damage to the case caused by the removal of the seal. To replace the inner bearing seal, use this seal replacing tool and a hammer or nut. As you see, the spindle must first be removed. Place the seal over the spindle near the inner bearing journal. Seat the tool properly over the seal and drive it until it is flush to the rear of the spindle. Normally, bearings do not become unserviceable after operating under unusual conditions. Where replacement is not required, this is how you would machine pack this type of bearing. First, remove the dust shield from the bearing packer and unscrew the packing cone. Then, place the bearing over the center stud with the taper side down. Screw the packing cone down on the bearing and tight. Now apply the grease gun to the fitting on the top of the center stud of the bearing packer. Operate the gun until you see the grease coming through the sides and tops of the rollers. The bearing is now properly packed. Don't forget the cone. And replace the dust cover immediately so as to keep the lubricant clean at all times. Should you find yourself in a position where a bearing packer is not available, you may hand pack this type of bearing. Notice the top is always kept on the grease container to keep out dust and dirt. Place enough grease in the palm of your hand and pack the bearing as shown here. As the grease comes through the sides and tops of the rollers, rotate the bearing until it is completely packed. Then, remove any excess grease from the tops of the rollers. Now, install the outer bearing. Tighten the inner adjusting nut until the wheel binds. Then, back off the inner adjusting nut as described in the vehicle's technical manual. Install a new nut lock and tighten the outer nut firmly. Now double check the wheel bearing adjustment. If you find that it is okay, finish the bearing adjustment by bending the tabs of the locking nut over the flat spots of both adjusting nuts. Using a new drive flange gasket coated with grease, install the drive flange over the splined end of the axle shaft and tighten the flange bolts. Use a torque wrench to tighten the flange bolts as specified in the vehicle's technical manual. Although the maintenance procedures you have just seen can be said generally speaking to apply to all types of wheel vehicles, each vehicle vehicle's technical manual dictates the specific maintenance procedures which must be followed in order to keep it performing at peak efficiency under the most unusual conditions. Military vehicles can meet